Hello, my name is Mateo, and today we're going to be talking about rolling element bearings. So, first we can see the catalog information. So, with each bearing, they all have different applications that might be used. And as you can see here, so if we look at the medium-sized bearing, um, the different sizes might be used for different loads and different it depends on what you want to do, and there's two different types. There is um, I'll scroll down here. There's the radial ball bearing, and then there is the angular ball bearing, these two. So let me get rid of that, and so yeah, that's what these two different types are here. And they have a catalog number, and that is what's right here. And you can see it for these ones too. So for the extra light series, it's going to be LL00. And so we'll get more into that down here. So as I was saying with the two different types, so with the radial, this one, it has an angle of 0, which is represented by alpha. And for the angular, which is this one, it can have 15, 25, or 35 for the angles of alpha. So if we scroll down, for when we're trying to select a bearing, um, it can vary on what you're the given problem. So here we're going to do an example where the bore size is 55 millimeters. So we're looking for the C value, which is the rated capacity. And this is for over um, the lifetime, which is lifetime reliability of 90 times 10 to the 6th, so 9 million cycles is how long it's supposed to survive. So for this one, we are given 55, and for bearings that are in diameter of 20 oops, millimeters or greater, you're supposed to divide by 5. So in this case, we have 55, and it corresponds to 12. And if we're looking for, let's say, this specific one, which is a radial bearing, it's going to be corresponding to the 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 catalog number, which is going to be 200. So the way we would write this, so since it's over 20 millimeters, we would divide by 5, which is equal to 11. And so that would mean that our number would be 211 for this bearing that we've selected. And be the same thing for the angular bearings on this side. And it depends on which ones you pick up here. And so next thing we're going to look at is the different variables for solving these problems. So C is what we just looked at, which is the rated capacity. C required, the required value for C for the applications. And then LR, which is a lifetime corresponding related to the capacity. And that's in revolutions. And then FR is the radial loading involved in the application. L is a lifetime corresponding to radial loading, FR, or life required by the application. And these are the two different sets of equations. So for we have the radial bearings and for angular bearings, where alpha is equal to 25, and here it's 0, as I talked about previously. And then last two things we're going to talk about is the application for Ka. So when you calculate Ka, you're going to um, find it. You're going to find a value. So in the one we did in class, we were given a Ka value of 0.65, and It's the life adjustment reliability factor. So if we're given 0.65, we would come to this scale, and you can see right here, and you go this way, and then you go to where it hits the curve, right? And then you go down to where you get your reliability. And so you would round up in this case, and you would say that you have a reliability of 95%, because you're obviously not going to say it's 94 point whatever, or you're not going to round down, so you're going to round up to 95%. And lastly, um, for bearing selection, based on what you're given, for how much the machine is used, you're going to select the design life. So if we were given machines for 8-hour service, but not every day, then we would have 14 to 20. So if it was like moderate, you would pick like maybe 20. And so that would be your lifetime value, which is L. So it would be 20,000, right? Because 20,000, because it's in thousands of hours. And so so for lifetime, it's actually in um, revolutions. So you would have to go through this. So it would be the lifetime value, which was 20,000, times minutes over hours, because you got to convert, and times the RPM you're given, and that's where you get the revolutions. And that's covers about everything. So thank you for watching. Hopefully this helped you, and that's about it. Have a good day. Thank you.